was so cool, but oh no, my bus is going to kill me. I didn't record anything.
I can help you with that.
Yes, please. I need to do all of this.
Let's go. By observing the movement of our object, we can see it forms a parabola. Now remember that we know its initial velocity and initial height. Step number 1. Let's establish our equation. This is the equation for parabolic motion, where h is height, t is time, g stands for gravity, VO stands for initial velocity, and ho for initial height. But guess what? This is just a quadratic in standard form where our variable is time. Now we can plug in the values of our problem into this equation. Since we are working in feet, we know that our gravity will be 32 feet per second squared, and we know that our initial velocity is 200 feet per second. Since the object was launched below the ground, our initial height is negative 10 feet. Now, when you graph it, make sure your y-axis is the height in feet, and let your x-axis be the time in seconds. Great! Now we have our equation. Now, let's find the vertex. Well, it is the minimum, or in this case, maximum point in a parabola. The vertex is a set of coordinates that in this context represent the maximum height of the object and when it reached it. First, we have to find the time or x-coordinate with the formula negative b over 2a. Here, you'll just simply replace the values from the equation we just created like I'm showing you here. Now that we know what the time is, simply replace that value in the original equation in order to find the maximum height. And there we go, we just found the vertex. For our last step, let's see if we can find the total time in the air. We are looking to find the time when the object is again on the ground, which means that the height must be 0. Now, we will get the two solutions or roots of the quadratic and then graph them. As you can see, one of them represents the time the object was above the ground after the launch, and the other one represents the total time in the air when the object completed its trajectory.
Thank you, you saved me. Now I have the best report of parabolic motion for my bus.
My report!
Oh no, I'm going, bus.